Okay, if you're watching this video, that means you've already attempted this entire worksheet. If you have not attempted this worksheet, please stop the video, attempt the worksheet, then come back to watch for any questions you may have had on the worksheet. In this first two examples, we're trying to decide whether the inverse is a function. So we're going to check by doing a horizontal line test. So I'm going to get my horizontal line. You can use your pencil, whatever it is. And I do the horizontal line test, and I notice that it does not cross my horizontal line multiple times. So the answer is yes. Alright, so yes, the inverse is a function because the original relation passes the horizontal line test. Alright, so we're going to do the exact same thing on the second one. We're going to take a horizontal line and we're going to check, make sure it doesn't cross more than once. In this case, it does cross more than once. So we see it crosses here and here, so we have repeating y values. So then the answer is no. The inverse is not a function because the original does not pass a horizontal line test. Now I'm just explaining it every time just to get used to giving me your reasonings for why things are the way they are. Oops. And I promise if you practice doing that, then you'll understand a little bit more quickly things about inverses and things about relations and functions. Okay, this next part, we're determining the inverse of each function algebraically. So remember, this had a few steps. First, you change your f of x to a y. Then you're going to switch your x and y, because an inverse is when your x and y are switched. And then we solve for y. So you're going to do your backward PEMDAS to isolate the y. And then remember, if it's a linear function, it's usually better to write it in slope-intercept form. So this is 1/5 x plus 4/5, because we're dividing each of these things by 5, is equal to y, because these 5's cancel. And then we need to substitute back into function notation. So we don't want the y here, we want f to the -1 of x equals 1/5 x plus 4/5. Alright, and then this is the inverse of that original function. Let's look at number 4. And you'll see this x is greater than or equal to 1/2. So what this is a domain restriction. And this is used to make sure that this thing is a function. So you don't really have to worry too much about that. But normally if you were to graph a square root or the inverse of a quadratic, you'd have something that looks like a sideways parabola. That x is greater than 1/2 is telling us that we're only going to have half of that parabola. So we're cutting it off. From the original function. Alright, so we're going to do the same thing. Rewrite this as y. And then we're going to switch x and y. And then we solve for y. So we're doing backwards PEMDAS to solve for y. Anytime you're isolating a variable, you can do backwards PEMDAS. We would get rid of any addition and subtraction. See the subtraction right here? You want to think you'd get rid of that, but because it's under the square root sign, it technically is asking as an exponent or parentheses. So we actually have to get rid of the square root first. So to get rid of the square root, we're going to square both sides. Square and square root are inverses, so they cancel out. So we're left with x squared is equal to 2y minus 1. Now we'll go back to our backwards PEMDAS, get rid of addition and subtraction. So I'm going to get rid of that 1. These cancel. We have x squared plus 1 equals 2y. And then we'll divide by 2 to get rid of our 2 in front of our y. Alright, and again, it's best to write this as 1/2 x squared plus 1/2 is equal to y. Now you can leave it in this form like we see on the left, but it's going to be harder to graph. This form, I can tell that we're going to have right here is a vertical shrink by a factor of 2, and then we're shifting the quadratic function up 1/2. So if I'm graphing by hand, this form is better. Alright, the last thing we need to do is write it in function notation. So f to the negative 1 of x is equal to 1/2 x squared plus 1/2. I'm just rewriting the function with that function notation. Okay, looking at number 5, again we have a domain restriction. We're going to first rewrite this as a y, then switch your x and y, because inverse, you're always going to switch x and y, and then we're going to solve for y. Isolate the y. First of all, I've got a fraction here. My variable that I'm solving for is in the denominator. I hate fractions. I know most of you probably don't like fractions. So we're going to go ahead and multiply by the denominator to get rid of the fraction. We have to multiply by the entire denominator, so that's why I'm putting it in parentheses. So my whole denominator crosses out, cancels out with the multiplication because they're inverses. So over here I'm just left with a 1. And then on the left side I'm left with y minus 4 times x. So we're going to go ahead and distribute the x. So xy minus 4x. Okay, and then we're trying to solve for y. So I'm going to move the 4x to the other side of the equal sign so that I'm isolating that y term. And then to get y by itself, we'll divide by x. So right now I have y is equal to 1 plus 4x all over x. I have this fraction, so I'm going to split it up. 1 over x plus 4x over x. We're dividing both things by x. Here we can go ahead and get rid of those. So the most simplified form is y equals 1 over x plus 4. And we're going to write that in function notation. F to the negative 1 of x equals 1 over x plus 4. So it's our rational function, 1 over x, shifted up 4. So we could go ahead and graph this by hand if we needed to. Okay, looking at number 6. Do that same thing over. I'm going to use a different color so it's easy to follow. Change f of x to y. Then we switch x and y. Now we're solving for y. So since that minus 1 is in parentheses, it's the last thing I'm going to get rid of. I want to get rid of the squaring. So the inverse of squaring is square root. Whatever I do to one side, I need to do the other side. Square root and square cancel. So we've got the square root of x is equal to y minus 1. And now we can add the 1 to both sides. We're adding the 1 after the square root, so we need to make sure it's not under the radical. So that plus 1 needs to be on the outside, so it's our square root function shifted up 1. We could easily graph that. Right, instead of y, we're going to write this in function notation. F to the negative 1 of x is equal to square root of x plus 1.